Hi, today I'm going to talk about absolute value and absolute value inequalities. Students first see absolute value probably in middle school sometime, and absolute value is defined as distance from 0. So absolute value of -2 is +2, absolute value of +2 is +2. So we only change the sign when the number is negative. So that's always either positive or 0. The absolute value of 2, like I just said, is absolute value of -2, and both of those are equal to 2. If you have a little higher up in high school, if you have the absolute value of x equals 5, then the answer can be either 5 or -5. Most students can follow along with that. Where it gets tricky is when we make more algebra, and then instead of using equals, we use flip signs. So the first one I have here is absolute value of x plus 1 equals 5. There's two answers. 4 is the easy answer. Often people will think it's -4. But if you put -4 into that equation, -4 plus 1 is -3. So what you really have to do is you have to make two different equations. The easy one, which is x plus 1 equals 5, and the challenging one, which is x plus 1 equals -5. When you do that, you get two different answers. One is +4, and one is -6. That's just an introduction to using absolute value with some algebra. Now what gets harder is when you do absolute value inequalities, and there are 4 different scenarios. First, I'm going to walk through the 4 different scenarios, mention them, and then have an example for each. So the first one is off to the races, and the second one is confined. The third one is everything under the sun, and the fourth one is nothing at all. So what happens with off to the races is if you try 100, 100 will work in that formula. The absolute value of x plus 1 greater than 5, 100 will work, but also -100 will work. And students have to be careful because when you do -100 plus 1, you get -99. So that's not greater than 5, except when you do absolute value bar thingies, then that is greater. So again, just like this example of here, you split it up into 2 equations. There's the easy one and the challenging one. The really challenging part about the challenging one is when you change this to a -5, you also have to change the sign, the flip sign. And so what happens here is that everything 4 and higher works, and everything -6 and lower works. And so you look at the number line, it's everything from 4 to the right and -6 to the left. And so I call that off to the races. We're going off in positive, negative affinity in both directions. Kind of the opposite example is x plus 1 absolute value has to be less than 5. And so we go through kind of the same procedure, except in that case 100 wouldn't work, and -100 wouldn't work. And so we just have a small part of the number line that's going to work. I call that one confined. Then there's 2 of the scenarios. One of the other 2 is absolute value of x plus 1 is greater than -5. Absolute value is always going to be greater than -5. It's always going to be 0 or positive. So any x value in the whole world will always work in this equation. The answer would be all real numbers, or what I call everything under the sun. When will absolute value, the fourth one, when will absolute value be less than -5? Absolute value will always be positive. When will it be less than -5? Never. So that one is nothing at all. Or in math terms, we would say the null set, because nothing would the absolute value of nothing would ever work to make absolute value negative. So absolute value inequalities, these are 4 examples of the 4 different scenarios. Thank you very much.